for many of our customers. And you need to be able to think through the overall process of transitioning from the current state to the end state, which is essentially what all the vendors in this space portray. There are a lot of steps that our customers, we have about 80 and counting of them, and 25 of them at least in the Fortune 500 league. Many of those customers have gone through a certain series of steps. And so what we thought we would do in this webinar is encapsulate and capture many of the best practices going through those deployments and talk about how we can transition from the network of today to the SD-WAN architecture and the network of tomorrow. So let's start off by talking about some of the basics. So in order to go SD-WAN, and since many of you are attending this webinar, I'll skip through the pleasantries of what the value prop of SD-WAN is or what the value prop of the Viptela technology is itself. Let's talk about how do you go from the network of today to an SD-WAN architecture. The first fundamental step that you will have to take, and it's an important decision to make, is whether you want to go hybrid or whether you want to transition from one type of technology to another. And when I say hybrid, it's essentially a customer using a combination of private MPLS, public broadband, and 4G LTE for a variety of reasons, for cost, accessibility, bandwidth, and also redundancy. Or do you want to go all broadband and maybe augment that with 4G LTE? And there's no right answer to this question. It purely is a function of risk appetite. It's a function of availability of circuits at a certain location and a function of what kind of SLA and what kind of redundancy do you want in your architecture. We've seen, interestingly, some of the highly regulated industries move towards broadband, and we have also seen not so regulated industries still stay with a hybrid option of MPLS and broadband. So that's kind of the first step. The second step is really whether you want to replace an existing device or whether you want to coexist with an existing device. What I mean by that is today the wide area typically involves a CPE connected into a private MPLS and potentially maybe another CPE or the same CPE that connects into internet optionally. And so the question to ask is whether you want to leave that infrastructure intact or whether you want to augment that infrastructure with an additional offering, or do you want to have an overlay on top of the existing infrastructure? So David will walk through multiple deployment options whereby you can have a CPE at the location, continue to function the way it is, and then augment that offering with a Viptela solution, with an overlay solution. Or you can just replace the existing one and then go completely full on with the overlay solution. And once again, the answer, there's no right or wrong answer here. It really purely is a question of what kind of a fallback do you want, what kind of a risk do you want to take, and also what kind of value do you get, and how quickly can you get as well. The third important question along the lines of what I just spoke about is whether you want to go all in or whether you want to go ease into the solution. And typically, if you have a network that's about 50 sites, I think you can make a fairly easy decision whether you want to convert the entire infrastructure in one shot or do you want to ease in. When it starts to get to 1,000 sites, 2,000 sites, 10,000 sites, and so forth, then you really want to have a phased deployment model. And this is not new. This is how networks have been built over the last decade. The question to ask is, there is going to be a period of time in between when you're going to have a SD-WAN portion of the network and you're going to have a traditional network coexist, which is still fundamentally okay. The question to ask is, how do you want to make sure that two islands talk to each other? Do you still want to have connectivity across all the sites? Do you want to have a bridge in between that connects the two islands? Those are kind of the fundamental questions to ask. And closely associated with all of this is, how are you consuming the service? Are you consuming this whole SD-WAN technology as a do-it-yourself model where you have expertise in-house, architecture, operations, and the associated planning? Or do you want to consume this as a managed service from, let's say, a telco or a carrier? Both options are equally good. Once again, it depends on how you're organizationally aligned, how you want to consume the technology, and what kind of personnel do you want to have in-house. After you go through the circuit piece, the decision on whether the CPE needs to remain as is or replace the CPE, and how long do you want to have two networks side by side, the big question that we have seen many of the customers ask is, now what do I do about cloud? Because the trigger point for SD-WAN is essentially either a high bandwidth application that's requiring a refresh in the circuits, and hence customers are looking for SD-WAN solutions, or it is, hey, I need to optimize my wide area for cloud, whether it's for infrastructure as a service or for SaaS. And especially with highly transactional applications like Office 365, the importance of designating certain points in the network as exit points, cloud exit points, becomes really, really important. And David will walk through the various architectures that we have and the various options that you have as well in order to adopt that. But fundamentally, this is an important question that you need to answer before you embark on this journey as well. And once you go through all of this, then there is a big question of organizational alignment. And not to scare anyone here, but organizational alignment here is we are fundamentally moving functionality around. What used to be traditionally inside a CPE now has moved to a few other locations in the network. So to give you an example, all SD-WAN solutions fundamentally need to provide the networking piece and also some element of network security, which means there needs to be a lean-in function with respect to security peers. And so there needs to be some level of organizational alignment there. There are also policy functions that cut across multiple organizations within a company. And more importantly, as you start to develop capabilities that are highly SD-WAN provided, you want to make use of some of the automation capabilities, some of the REST API capabilities, and so forth. And so what we've seen customers do is actually embark on the equivalent of a DevOps or a Cloud Ops, but have some kind of a network operations team. It could be a team of one, or it could be a team of people, but the roles and responsibilities of that team are essentially to highly automate the infrastructure. And automation is not just configuration automation, but rather the workflow. If I get visibility around loss, latency, jitter, and so forth from the underlying network, and I also get application visibility, how do I tie all these things together beyond what just the native network can provide? So the SD-WAN portion of the network gives you enough intelligence, but how do I tie this now to maybe a security appliance? How do I tie this now to the data center piece and maintain segmentation end to end? So all of those really tie back into some level of automation, whether it's in the form of scripting or whether it's a form of a tool that you use on top that can automate workflows. That becomes a pretty important decision, and alignment is required in order to be successful. And we've seen this as a common theme across, again, the 80+ customers that have deployed this technology, and especially as we start to talk about large deployments. We have a couple of deployments that have gone way past 1,000 sites, and we see these kind of principles kind of play really well, and it helps ease the overall transition as well. Ultimately, at the end of the day, if we were to do a marketing pitch, we would say SD-WAN is great, you have to fly, but having gone through the deployments, we want to make sure that customers go through a certain journey, and the journey may involve setting up a few sites at a time and essentially crawling there, get comfortable with it, and then start to roll out maybe 20, 30 sites a day, which would be the walk transitioning over to the run. And once you have all of the items automated, whether it's site bring up, a policy bring up, network upgrades, or any changes that you want to make, then you can start to fly as well. So with that as the backdrop, I'll transition off to David, who will walk through the technology elements, the architectural elements, and also what is the first step? As they say, a journey of 1,000 miles starts with a single step, and it's important to take that first important step. So David?
Talking about the specifics of what you've heard before from Lloyd and Ramesh. So how do you start, right? So you have bought into a vision of SD-WAN. You understand the principles of SD-WAN. You understand how SD-WAN is going to transition your business. But where do you start? As you've seen with the previous slide that Ramesh was talking to, it's a journey. So the journey has to start somewhere. So we have drawn quite a lot of experience from our deployment, and here's what I wanted to share with you in here, is that look at this drawing. So on the left, you can see your traditional existing MPLS network, which is based on your existing CPEs. Now, you want to go and ease into looking into how SD-WAN is going to be incorporated into that network. So many organizations want to start slow and ease into this. So what we observe is that people are deploying a side-by-side software-defined wide area network by introducing the new CPE devices. In this case, these are Viptela VH routers, and those are connected to just an internet circuit. This could be broadband, cable, anything that is not consumed by your production environment. That allows you to create sort of a safe environment to experiment on and selectively send traffic from site A and site B. And those site A, site B could be two branch offices, a branch office and a data center, a branch office and a cloud, a data center and a cloud. There's really no distinction what site A and site B really means. These are just the two locations within your network. So this is a very safe approach if you want to sort of just to get an experience in running SD-WAN. Now, what are other start points that you can have? So a more meaningful starting point is that you want to extend your SD-WAN network across both your existing transport, which is your primarily MPLS, and your broadband transport. In this case, you build a connectivity across your existing routers, across your existing CPEs, to establish this active path. The path traverses your existing infrastructure, so you can run two types of traffic side by side. You can have your existing traffic still going through the existing routers using what you can think about as an underlay path, and then you can have an overlay path, which is the traffic that would be hitting the VH routers first, and then choosing either the tunnel that goes over the internet or the tunnel that goes over the MPLS. You can see in here there is no need to provision a connectivity to the MPLS or direct connectivity to the MPLS network from the VH router CPE device, and it's dependent on the existing router to use that router's connectivity to the MPLS network as a means to establish that secure virtual network. Now, there are cases where an additional connectivity to the MPLS network is also possible. In this case, you can see the difference on the picture on the right is that the VH routers, the CPEs, actually have a connectivity into the MPLS network directly, in which case they're able to establish the secure virtual network across an MPLS network without passing across or on top of the existing CPE devices, existing routers. Again, all three approaches allow you to run in parallel your existing traffic through the underlay and your traffic of interest that you would like to start using the principles of the software-defined networking. And two types of traffic can run in parallel, whatever your starting point is. At the end of the day, what you are trying to get to is you're trying to maximize on the benefits of the SD-WAN, and you're trying to get into a situation where you have simplicity that SD-WAN brings. You have the redundancy. You can see that an existing CPE device was replaced by the redundant VH device. And you now have a native SD-WAN connectivity across all of the transport that are available to you directly without any dependency and or reliance on an existing CPE devices. And again, those CPE devices basically with time can be replaced. You can transition from the previous slide, the three beginning steps that you can take to this target state architecture. Now, of course, this does not happen overnight. So it will take time to transition from the hybrid environment where you have an existing and the new SD-WAN into an all SD-WAN environment. That journey can last anywhere between months and years. So let's look briefly at how can two worlds coexist and interoperate in that interim term that you have both solutions running in parallel. So the starting point is the hybrid network. So you have some portion of your network that has already transitioned into the SD-WAN approach, and that would include a certain amount of data centers. Those could be regional data centers or global data centers. They can be in one geography or multiple geographies, but you have a certain amount of data centers that have transitioned to an SD-WAN network. And then you have a certain amount of branch offices that have transitioned into the SD-WAN network, and this is the sort of, think about that as a core of your SD-WAN environment. Now, side by side, you have sites that are only on the MPLS network, so they're exclusively connected to the MPLS network, and these are the remote sites that still have not yet migrated into the SD-WAN environment. And then you also have sites that are exclusively on the internet. Neither one of those sites have transitioned to SD-WAN. So the question is how would those sites talk to each other, and how would those sites interoperate with the sites that have migrated to the SD-WAN environment? So the simplest way to do that is to extend the SD-WAN fabric across those existing transports, so an MPLS or internet, into the data centers that are the interconnect points between the sites that are sitting on the disparate transports. So you can think about the data centers as pieces of an element that glue an MPLS-only site and an internet-only site into the cohesive SD-WAN fabric. Of course, you can, at any given time, you can add an MPLS transport into the internet site, or you can add an internet transport to the MPLS site to provide this fully meshed fabric. But this is an optional step, and some of our customers are happy with having this sort of a diverse approach of having sites that reside on only a single transport. Now, in addition to those, there could be sites that have not yet migrated to the SD-WAN network at all. So these are the sites that still operate in an underlay or MPLS underlay space. So if you think about what are those sites, these are the sites, as I mentioned, the ones that have not yet migrated, and also the sites or also the services that you are consuming from the MPLS service provider, and these are provided in the underlay space. The example of those are security services or voice video control services. So what's your way to communicate from the SD-WAN environment to this non-SD-WAN underlay environment is, again, you can make use of data centers, in which case you can establish a BGP routing relationship between the PECE devices on the MPLS network, and to extend the reachability from the SD-WAN fabric, be that on the hybrid network or an MPLS, exclusive MPLS or exclusive internet, into the sites that have not yet migrated at all and are sitting only on the MPLS network without any SD-WAN awareness. There's also an option for you to create a shortcut connectivity from the remote side directly by establishing a local BGP relationship between the PE and CE devices. Now, to double-click a little bit on what it means about establishing a BGP connectivity between the PE and CE devices, and in this picture you can see that you have three sides. You have the remote side, you have the data center side, and you have a legacy side that have not yet migrated, and there's an MPLS network in between. The SD-WAN network, and in this case we are demonstrating the SD-WAN network that makes use of an overlay management protocol to distribute all the information about reachability and security characteristics across the sites that are participating in the SD-WAN network. So you can see in here there's three subnets. There's 10.10.10.1 at the remote side, the 10.10.10.2 at the data center, and the 10.10.10.3 which is at the legacy side. If you look at the routing tables of the CPE devices or the Viptela VH devices, they of course have a reachability into the other sites' networks that is advertised across the overlay network. But they have no visibility, and they have no routing information about the site that is residing at the location that have not yet been SD-WAN enabled. Yet that location has a BGP peering to the PE device. So this is a very standard practice in the MPLS world, where you have a BGP peering between the provider edge device and your customer premise device or customer edge device. So the way that you would integrate this legacy side into the SD-WAN infrastructure is by enabling a BGP peering on the data center side. And again, we're talking about the data centers as providing a means of connectivity between the overlay and underlay world. And by enabling this, we immediately start learning the reachability for the legacy side through the underlay, with the next hop being the provider edge device at the service provider location. When that information is learned, it is also advertised through the OMP to the remote side, and you can see that 10.10.10.3 would also appear at the remote VH's routing table. So in fact, we have now established a reachability, which is a native SD-WAN reachability between the networks that are on the SD-WAN fabric, and also the reachability from the remote side through the overlay network to the data center and onto the underlay network into the MPLS network to get reachability into the legacy site. So this is one example is how you can integrate a site which has not yet been enabled and is residing in the underlay space in the MPLS. Now, we also briefly mentioned about the cloud previously. So some of the triggers for SD-WAN migration have to do with cloud. So let's talk very quickly about two types of clouds that you can be looking at. The first is the infrastructure as a service cloud. So you are a private cloud environment. You're trying to transition into the public cloud, or you're trying to enable a hybrid cloud connectivity. So you have your existing SD-WAN network that consists of the sites, campuses, branches, and the corporate data centers, and yet you have a cloud data center resources. Those could be residing on public clouds, for example, in AWS or Azure clouds, or Google Clouds, or SoftLayer, or whatever flavor of the public cloud that is out there. And the question is how do you bring those resources into your SD-WAN fabric? So the most convenient way of doing that is by instantiating a virtual CPE device. You can think about this as a virtual Viptela VH device, which is residing directly at the cloud infrastructure, and it's becoming an integral part of your overlay. And now that cloud data center site is basically becomes another location on your SD-WAN fabric. So this is very, very easy, very streamlined way of incorporating infrastructure as a service environments into your SD-WAN fabric. The second one you can look at is how you adopt or start adopting software as a service cloud applications while maintaining the quality of experience to access those cloud applications. And this is where one of the most important things is how do you choose which locations out of your network are designated as a point to access those cloud applications. And you have choices, you have flexibility. So the first one you can opt into is by leveraging the cloud security, which is where traffic is allowed to go directly from the remote office to the cloud applications. Yet, if you're concerned about securing that communication or maybe creating some policies around what's enabled and what kind of traffic is allowed and what kind of traffic is not allowed, then you can employ things that are cloud security. So your traffic is on its way to the cloud applications must pass through a cloud security provider network. In our case, we have a very tight integration with Zscaler secure cloud gateways. The second option is that some of your locations, such as larger campuses, could have an on-prem security elements such as firewalls, IDS, IPS devices that are provisioned there. Those are very sort of traditional way of looking at delivering secure cloud application access by just inspecting the traffic that is going to the cloud applications that reside on the internet before it's being allowed to exit your network. It's been subjected to the security enforcement point. Finally, the approach of a regional security, which is gaining a very significant interest from many customers that we're working with, is that how do you maintain the level of security, and you're not quite comfortable with the cloud security. You still want to have your own security enforcement points in your network, in your data center, or in your regional data centers, yet you are not comfortable of deploying firewalls at every one of those remote locations. In this case, a model of a service insertion through the regional data centers plays very well in that. The way that it's being adopted is that you have a certain layer 4, layer 7 services that or nodes that are being advertised into the SD-WAN space, and those can be firewalls, IDS, IPS devices, or whatnot. Those are advertised into the SD-WAN fabric as being available, resources being available to be consumed, and then through the SD-WAN policies, you can steer the traffic to those regional data centers based on the QoS characteristics that you need to uphold for those cloud applications. So the choice of the regional data center is tightly integrated with what is the quality of service that you want to observe. So it's not just connectivity, but it's a connectivity with the quality of service. And that traffic is steered from those branch locations into the regional data centers where it's subjected to the security inspection, and from those regional data centers it's allowed to proceed into the cloud applications. So these are the two sides of the cloud adoption: the infrastructure as a service adoption, where you can seamlessly make it part of your network, and the software as a service adoption, cloud application adoption, in which case you can be very crafty and very flexible about designating the points of access to the cloud applications while keeping them secure, and more importantly is also upholding the specific quality of service characteristics while accessing those cloud applications. So with that, I'd want to open it up for questions and see if we had any interesting things we want to bring live and answer some questions for the time that we still have. So Lloyd, Ramesh, anything you want to bring up that came up in the last 15 minutes or so?
Sorry, I was talking to a muted phone. So yes, actually a few questions have come about. And David, if you go back to the migration steps, I think it will be easier to explain with that. So the question is really around as you go through through actually this slide, please.
Oh, the slide, this guy?
That's right.
All right, let's just build it out.
Yeah, so the question is really around, so the existing sites continue to be the way they are, and how do you integrate routing into the mix? So, and there's a mention of the word OSPF and BGP here. So if my data center is running BGP and my branch is running OSPF, then can this still continue to operate? So David, you want to take that?
Oh, sorry. Yes. So the use of routing protocols is very important. It's essential. It's mandatory to be able to interoperate between the existing world, which is driven by the routing protocols, and the SD-WAN world that makes use of the routing protocols, yet builds a logic on top of it. So routing intelligence and the comprehensive routing intelligence is really the common denominator across all things network. So as we have outlined in this slide when we talk to that, is the use of the BGP protocol to interoperate with an existing MPLS network, and a BGP is a de facto standard for an MPLS deployment. The ability to deliver the BGP intelligence and incorporate that BGP intelligence into the overlay routing that is existing on the SD-WAN fabric. These are an extremely important essential elements of the solution. And it's not just the support for the routing protocols on the edges of your network, but it's the ability to extend that routing intelligence across your entire network. And so there's lots of things that come into the considerations, and these are the things that we're working through with our customers when we are having architectural discussions, when we go to the proof of concepts, when we have production deployments. These are the things that are not trivial. These are the things that require careful consideration and careful planning and strong expertise in both secure overlay fabrics and underlay routing protocols to be able to deliver a meaningful service. It is not. It is absolutely not a trivial problem to solve.
Right, and closely associated with that are a couple of questions. One is to create the overlay tunnel. Do the VHs need to BGP peer with the MPLS network first to learn the destination networks? And the short answer is, in order for two sites to talk to each other over the MPLS network, you need to be able to know the transport IP endpoint. Essentially, what are the IP addresses or the location endpoints of the various CE devices that are talking to the PE devices. And in most cases, that's learned through BGP, through a service provider. So in order to create an overlay over the MPLS network, yes, you do need BGP, but that BGP need not carry the customer side prefix information. So all the prefixes that you have, let's say inside the data center, inside the branch, need not pass over that BGP session. Those things can still continue to go over the overlay network and does not have to be in the MPLS network at all. So you do need to enable BGP, but it's only to learn about the reachability for the PECE connections on the remote end. And I think that brings us to the other question around zero-touch provisioning as well. So if you have a device that is connected over only MPLS, can you do zero-touch provisioning? The short answer is if the PE is DHCP enabled and the CE does not have a static IP, then you can actually learn a DHCP-based IP address and then use that to do a full ZTP. What we have seen is many of the provider edge devices across multiple carriers do not support DHCP-based IP address assignment to the CEs. And so naturally, as a result of that, you have to configure an IP address on the interface, at which point it becomes a one-touch provisioning. So all you need to do is configure an IP on the CPE device or the CE device connecting into the PE, and the device would still go through a full zero-touch provision process, authenticate, pull its config, and then the operational network will be okay after that.
Right, and it's probably worth mentioning that we are working on enabling zero-touch ZTP process over an MPLS network. So stay tuned for that too.
Right. A couple of other questions. One is, what's the impact to host on a virtual machine based endpoint, and how much CPU does a SD-WAN VM eat for solution that uses VMs? The short answer is it depends on capacity. So we do provide guidelines around how much of bandwidth encrypted throughput you can actually push through a a VM with one or two vCPUs, you can use that as a benchmark, and you can scale that up linearly as well, depending on capacity. So you can say, hey, the unit is, let's say, 100 meg, 300 meg, 500 meg, whatever that is, and then I throw in as many vCPUs as the problem, and I can linearly scale the bandwidth as well accordingly. Okay. So David, a question for you. How much latency does the SD-WAN controller introduce?
Right. So the SD-WAN controller introduces absolutely zero latency. And SD-WAN controller is a fully off-path element. It has no data communication that happens between the VH routers and the SD-WAN controller. So SD-WAN controllers could be completely remote, geographically dispersed in any part of the world, as long as they have an IP connectivity between the VH routers and the controllers that we call the vSmart controllers. So the VH routers and the vSmart controllers need to have an IP communication between themselves to exchange relevant information, but there is not a single data packet that goes between, so there is a zero increase in latency based on the geographical location of those controllers.
Right, and in fact, just to give you one of the extreme examples that we have seen, there is a controller out here in Southern California that's actually controlling a couple of sites, one in the Middle East and another one in London. And so you're really talking multiple, not just geographies, but continents as well as a result.
Right.
So completely on a different topic around, or going back to discussion on BGP, is BGP the only routing protocol that's supported in this case? And then the short answer is no. We support the full variety of routing capabilities from static to connected to OSPF to BGP. Not just that, but we can also do best path across all of them. And this goes back to what David was mentioning earlier. If I have a site that's connected, let's say a head-end site that's on BGP, and a default route from there goes through the MPLS underlay and is advertised as an OSPF route through one of the other sites. Well, guess what happens? You have an interesting best path computation that needs to happen. And so these are, again, some of the things that you encounter in the actual process of deployment, and there are enough mechanisms and tools in place so that you don't have to think about these things. The system is intelligent enough to figure out who the source of a certain subnet or a prefix is, and it can avoid loops and compute the best path accordingly. And in some really, really complicated cases where you completely lose the origin of the route, then you can also put policies in order to prevent these type of things.
Right. Absolutely. Yes. It's the routing intelligence is something that needs to be propagated across the network, and it's not something that gets deployed at the edges of your network because that's just not how you build networks.
Right. There's a question on encryption, especially for countries that require lower grade encryption, and the short answer, it's a much elaborate answer, but the short answer is yes. We do have the ability to go lower on the encryption side. There are some that require 40-bit encryption and below, at which point I would safely say it's okay to use GRE, because if we can break that in an hour, why bother encrypting? So, but the short answer is yes, we can support GRE, null encryption, lower grade encryption, or full AES 256 with 2048 as well, 2048-bit as well. Another one for you, David. What about encapsulation? Is it standard or proprietary?
Right. Encapsulation is absolutely standard. We use standard IPsec data plane protocol between all of the VH routers in in our network. We do not use any additional encapsulation, so it is a traditional standard IPsec encapsulation natively running over an IP network with no additional encapsulation overheads.
Right, and I think there was a request to show the interface, and I believe that means the management GUI through this WebEx. And the short answer is, I think this particular WebEx session, the webinar that we have scheduled here, we were not planning to, but we have in the past shown multiple demos with the management interface. So you're welcome to look at those, or we'll be happy to set up a call with you and go through that in detail as well, if there's interest.
Absolutely, yes. As we were sort of trying to balance the time, we preferred to give you more meaningful information about how the system operates, rather than spend the time clicking through the GUI elements. But everything that we talked about so far is backed up by a comprehensive GUI that you would be consuming, and that's what we call a vManage, which is a single pane of glass for managing, monitoring, operationalizing, troubleshooting your entire SD-WAN environment. So everything we talked about is backed up by a comprehensive GUI element as well.
Right, and I think we have time for one last question, and David, that's for you. What happens to in-flight traffic when a tunnel dies?
That's a very good question. So, in-flight, so what we do as far as distributing the traffic across the tunnels is we support a per flow load sharing, which is years proven in the networking industry as the best possible way to send traffic across multiple paths without introducing things like resequencing packets, which are very computationally intensive things. So we are following an industry-proven practices. So for the traffic that is already in flight and is being sent across the network, so that traffic is, of course, depends where the failure sort of occurs. If it occurs in front of the packet, then the packet will be lost. If the failure occurs behind the packet, then the packet will be delivered. So it's a little bit of a tricky question. We'd need to investigate this sort of further where the failure occurs. But at the end of the day, when the path goes down, the system seamlessly starts using all other means or all other tunnels that are available as a connectivity between the two VH routers. So at any given time, there is no, as long as there is a path between the VH routers, the traffic will be delivered either across a tunnel or across multiple tunnels with active per session load sharing. There is absolutely no consideration for things like rerouting the traffic or rerouting mid-flow. All of that is absolutely industry standard things that are years proven in decades of experience.
Okay, I think that's all the time that we have. So thank you everyone for listening in, and there are a few other questions as well. We'll follow up with you individually on those questions. Thanks again for your time, and we look forward to seeing you in another webinar.
Thank you very much, everybody, for joining. Hopefully this was informative. Feel free to reach back to us or check out more information at viptela.com. This webinar is also going to be posted, so the first slide has our contact information as well. So feel free to reach out for any clarifications you need. All right. Thank you very much.